Hello, SSD members and viewers around the world. Today we're going to be giving a brief talk on build pipelines, the process in which your code goes from being complete to being deployed in production, and how it relates into the larger DevOps picture. You might notice that there's no camera from a Zoom meeting right now. Unfortunately, when we gave this talk live on Tuesday, the audio became completely garbled, and I tried listening back to it, tried upscaling it, but you can understand part of it, but it's just a really unpleasant experience if you're trying to sit down for 30 minutes and learn about a topic like this. So decided we're just going to completely re-record the workshop, and hopefully you guys on YouTube will get a much more polished version. Tuesday was a bit chaotic. So you guys, when you get to your internships this summer, are going to be doing a lot of really cool work. And one of the proudest moments that you will have during your internship will be when you get to finally reveal your new feature to the world and get it into the hands of the users. Now, the question is, how exactly do you do that? You just finish your code and then release it, right? If you've released your own personal projects before, some deployment tools out there make it really easy. If you use something like Netlify and you build a web app, you can just drop the folder output into it and it's deployed, and that's it. However, in a real company, it's a bit more complicated than that. You got to go through staging and PRs and CI and QA and CD, and I swear all of those acronyms actually mean something. This confusing series of acronyms right here is what we call a build pipeline, which are basically the steps that happen after you finish working on some code but before it is released to production. So these are the steps that you basically go through to make sure your code is ready for release and to actually release it. Now, this is very important for you to know because one, this is one thing that absolutely does not get taught in classes, and two, there's a very good chance that in your internship, when you finish working on your feature, you're going to be told it's time to go deploy this, and you don't want to be caught off guard and react like this when that happens. So we're going to go ahead and go over those 5 aspects of the deployment pipeline today. First one is going to be staging environments. Second one is going to be pull requests, which is probably the one that you guys are most familiar with already. Third one's going to be continuous integration. Fourth is quality assurance. And fifth is going to be continuous deployment. So let's get right into it and talk about staging environments. Now, to be honest, this one comes into play while you're still working on the code and development, but it will also come into play during the deployment process too. So let's talk about this first. Now, let's begin by just kind of going over the basic architecture for a lot of web apps nowadays, which is you have some basic front end running in a user's browser. It makes calls to the back end to retrieve data, and that back end stores and fetches data in some database somewhere, right? A lot of you guys have probably seen this model before, worked on it, whether in your own personal projects or at companies. Now, one problem that you run into while you're running this model is that while you're writing the code for the front end, you can't call the actual production backend, right, when you're adding new features. And similarly, when you're writing code for the backend, you can't make calls to the actual production database. Why is that exactly? Well, the reason is you can't mess with user data, right? Obviously, when you're writing new code, sometimes things might go wrong. You might test some things out. You might be running experimental features that might never even end up being released to the public. And if you're working with real data while you do this, there's a chance you could mess something up. And messing with user data is something that could destroy an entire company, right? Imagine if some intern at Instagram accidentally wrote some backend code that deleted everyone's profiles, right? The world's productivity would probably go up, but all the users of Instagram wouldn't be very happy. So that is not something that you can afford. So the real question is, how do developers in the real world deal with this problem? Well, instead of calling your production backend or production database, they use something called a staging environment. And this is basically a duplicate that you have running in the cloud of all of your services. So you'll have a duplicate staging backend and a duplicate staging database. It's used for development and for testing. And the important part is that it's got completely fake data, right? None of the actual important data of your users is stored here. And that means that you can pretty much go crazy here and not have to worry about hurting your users if something goes wrong. Now, some of you guys might be thinking, well, if I need the backend or database to not mess with users' data, why can't I just run them locally? And the short answer is you can. It's definitely something that is probably the easier option for personal projects, right? And even at companies, I've done this before. But there are several situations where this just isn't ideal. Imagine that we have our front-end developer over here, and he's not full stack at all. He only touches the front end, and he only works with the back end through API calls. Would it really be the best use of his time to know how to set up a back end that he never works on and that he has no expectation to contribute to ever? It's probably not a good idea. An even more kind of extreme example of this could be if you have microservices. Now, quick recap. Most of you guys have probably worked with monolith backends before, which just means that it's one program that has everything. So every piece of your backend is running together on the same executable on the same computer. And it's what you're used to, right? Pretty much every single person watching this, if you've written a line of code before, you've written a monolith. However, microservices are when we take that backend and split it up into different programs that run on different computers and are talking to each other over a network. And this means, crucially, that they have to be deployed separately and set up separately. Another kind of thing that can make this more complex is that each microservice will often have its own database. So that kind of makes this separate deployment and setup issue here a big reason why you would not want to run your backends locally if you're doing microservices. Because imagine you're trying to work on code for just one microservice and you have 3, right? Do you really want to have to set up the other 2 locally just to work on the first one? It just doesn't seem like a good use of time. Or what if you've got 4, 5, 6, 7, 8, who knows how many microservices? If you're at a big tech company, this might be your reality, right? It's just not a good use of your time. And if you're thinking of doing this, stop. The beauty of a staging environment is that you just need to worry about the setup for the service that you're working on, and you still have a clean, safe environment to do all of your development and testing on. Now, how do you use a staging environment? Environment variables. Now, if you guys aren't familiar with environment variables, they're often stored in something called a .env file, and they're typically at the root of your project, although you can have multiple. And they store variables that change depending on the environment that your program is running in. So something that might be different on your development machine as opposed to in production. And they also store things called secrets and tokens, which are basically passwords for APIs and other things that you don't want being exposed. And it's very important that you never, ever commit an env file to Git, because even if you remove it in a later commit, it's stuck in your commit history, and attackers do crawl through GitHub repos trying to find old API tokens and stuff. So put it in something called a .getignore, which we'll show you in a second. Now, this is an example of what a .env file might look like, right? We have a variable called backend URL, and it stores the URL to our backend. Now, let's say this is the URL to our production backend. If we want to switch this to staging, how do we do it? Well, you just switch to the staging link. And to show you that this works, I'll do a really quick demonstration. So right here, I've got just a 4-line program in JavaScript. Basically, this is just going to load in an environment variable and then print that environment variable to the terminal. So this is using a library called .env. This is the most common one for JavaScript and TypeScript. Exactly which one you use will depend on the programming language, but most of the time you'll use a library to parse the .env file. And this right here is a .env file yourself. So it's just like Minislide, variable name equals whatever value we have here. And we're going to pretend we have a URL that's going to call some kind of backend. So if I run this code real quick, pm start, so you can see the backend URL, mybackend.com. If I want to change this to staging, though, I can just come to .env, change URL here, so it's a staging.mybackend.com, save that, run npm start one more time, and this time the URL has changed. And that's awesome. Even if you're on a development, even if you're running your backend locally, you could still just easily change this to say localhost 8080 or whatever port you're running your backend off of. And if I run that again, that URL is changed everywhere it's used in my program, and it's only in one place. Now, one more thing about not committing this, how do you prevent your .env file from being in your git commit history? You use something called a .getignore file. It's basically just a file you put in your project that lists things that you don't want to be added or committed to Git. So as you can see, I have .env right here. So Git knows if it sees a file called .env not to commit that. So we went through staging environments. You use them for development. Again, they will come up briefly later on. But for now, we've actually finished writing our code. Are we done? Absolutely not, because we actually have to get it through the release process now, and that's going to bring us to pull requests, which are probably the part of this that most of you guys have had at least some exposure to. Now, pull requests are going to be done using the world's most user-friendly software ever created, Git. And most of the time, your code is going to be stored up in the cloud in some kind of remote repo. GitHub is the most popular service for this, but there are alternatives such as GitLab and Bitbucket. And another idea that you should be comfortable with is the concept of branching. Now, a branch is basically a copy of the code base that you can create within your Git repository, and it allows you to make changes without affecting other branches and then merge those changes back into the other branches later. So you can work in parallel with other people without impacting their work. Now, to show you a quick illustration of this, let's say you've got the main branch or the master branch, depending on what you call it, on your project. And I want to develop a new feature for it. What I can do is create a new branch. It's typically called a feature branch. And then make some new changes on that new branch. Note that nothing has changed on the main branch yet. And I can do multiple commits. So if there's multiple changes I want to make, I can do that. And when I'm ready, I can merge those changes back into the main branch and they become one again. And those new changes are reflected. Now, this is really useful because other people can keep taking new code from this main branch and not have to worry about my work in progress affecting anything here. And it's really important for the whole development process. So now that's going to bring us into pull requests. A pull request is when you ask to merge your branch into another branch. So most of the time in companies, your code has to be approved before you can merge it into the main branch. If you guys have worked on personal or group projects before, let's be honest, we know a lot of you guys allow pushing straight to master, but that doesn't fly in most companies. And you have to go through a process called code review, where basically the other engineers on our team read over the changes you made to make sure that you didn't break anything and that your code is up to quality. So here's what the process for that looks like. You'll create a new branch on the remote Git repo in the cloud. So imagine GitHub. You'll push your changes from your local computer to the remote repo. You'll open a pull request saying, hey, I want to merge these changes into the new branch. You'll have some coworkers on our team review your code, and there's two things that can happen from here. One is that they say you have skill issues and you need to fix your code, basically. And so what'll happen here is you'll go back on your local computer, keep making changes, make some new commits, and then once you've made those new commits, you can push those changes back up to that same branch, right? The same branch that you opened the PR for. And then once you've made those changes, your coworkers will look at the code again. And if there's still problems, then you'll keep going in this cycle. But eventually, once everything is all good, your pull request will be approved. And then you can merge your code into another upstream branch in your remote repository. So here are some examples of what a comment in a pull request might look like. One very common thing that might get pointed out in a pull request are just naming conventions and style conventions. And if you want to learn how to be good at that, check out our Rules of Readability workshop. It's right here on our YouTube. Here's another example here about formatting. Here's an example of a pull request from our SSD website project. This is from Blake and Angel, who you guys both know from our previous workshops. This is a really great example of not just what someone correcting you might look like, but how to respond to feedback. Pull requests are always a good learning opportunity. So make sure whenever your reviewer leaves a comment for you that you respond politely, and also make sure that you respond to their comment and let them know, because typically they'll get an email notification when you do that, which will remind them to go back and look at your code and approve your pull request as quickly as possible. I cannot stress that, because sometimes pull requests, sometimes in a company you might just end up waiting for a pull request for a few days, and sometimes that can be tricky if you have other features that depend on you getting this piece of code out. So always try to make sure you respond to your reviewers. So now when your changes finally get approved, are we done? No. This is just a human approval. We need the robots to approve us next, and that's going to bring us into continuous integration. Now, this is another one of those fancy terms that you've probably seen on the LinkedIn boards when you're applying for jobs, but continuous integration is really just automated testing. That's all it is. Basically, you can set it up so that anytime you push to a branch on GitHub, or you can have other events trigger it, you can automatically have certain checks run on your code. And if these checks fail, it can block you from merging your code into main, just like if you fail the pull request. And this is an example of what it would look like on GitHub if you failed something. There's a good chance you will probably see this screen at least once during your internship. As you can see, we've got a whole row of tests here, and it's telling you which one failed. We'll look at an example of how to parse this information in a second. But, major question is, what kind of stuff can you test with continuous integration? Really anything that you can put in a script, right? So first and foremost, unit tests. If you guys aren't familiar with unit testing, a unit test is basically when you just test an individual function. You can do integration tests, which are when you test your whole application, testing a specific feature from end to end. You can test your test coverage. So what percent of my code is covered by tests? A lot of companies have policies that might say, hey, we require all of our code base to have 80% coverage, for example. And you can set it up with your CI to reject any changes that don't meet that threshold. So if you add a whole bunch of new code, but you didn't write enough tests, it might be blocked from merging. You can also do style checks. Again, make sure you can run auto formatters to basically check that everything looks good, that you're not violating any style concerns. And most importantly, make sure there's no compile or build errors. The last thing you want is to ship code that literally is broken into production out to the users, right? So that's really the main idea of continuous integration. You want to block broken code from production, and you want to block poor quality code from production too. Now, there are several providers of continuous integration. GitHub Actions is the one that we'll show you in a second. It's built right into GitHub, so that's really convenient. Circle CI and Jenkins are also really popular choices in the industry. With GitHub Actions specifically, it works by using something called a workflow. And what a workflow is basically just an ordered list of scripts that runs whenever a certain event happens. It runs in a container, and again, it's just an ordered list of scripts that runs after a certain event happens in your repo. So let's look at a quick example of one. So if we come over here, this is a quick little continuous integration demo that we're hoping to get a small YouTube demo out. This workshop is more about how to read these and use them, because most of you guys probably won't be setting up continuous integration at your internships. But with GitHub Actions, is actually surprisingly easy to add this to your own project yourself. So hopefully we will have that in a separate video soon. For now, I just want to show y'all how to use it. So whenever you have code that gets pushed to a branch, let's say I have a pull request that I opened right here, GitHub will automatically run the tests in your continuous integration, and it will either tell you that your checks passed or failed. I have a check here that is intentionally failing. So if you see this, what you can do is come down here, look for the test that failed, and then hit details. As you can see, it will show us a list of all of the different scripts that basically ran in our test. And as you can see here, I've got run tests that failed. So let's expand this and look at the logs to see what went wrong. Now it looks like here, fail multiply two numbers test.js. It says it expected 40, received 20. So it looks like that we had a failing unit test here, right? And it's failing because I intentionally put an error in the code to demonstrate this. So if I come back to code here, oh, sorry, it was on another branch, my bad. If I come to the branch that this change was on, as you can see, I have an X right here telling me that the build failed. Come to multiply two numbers, you can see I intentionally made this wrong. So let's go ahead and fix that so our continuous integration passes. So I'm going to come to the code here. Let's get rid of that intentional error. So if you multiply two numbers, A and B, it should just be A and B. Save that. Briefly commit that to Git. So let's do git status. And just in general, to show this is working, let's just run a test now. In general, it's good practice to just, before you open a pull request, just run your test suite locally. It's much less of a headache than waiting for the build process to run, realizing it failed, and then having to go back, fix the change, and then push it again. Especially if you already asked your coworkers to go and review it, and you got to tell them, oh, never mind, the build failed. As you can see, unit test is passing now. So let's make sure I've added that, and let's go ahead and commit that. So fix multiplication error. And then let's push that back up to the branch where we had our changes. So git push origin, add multiplication. It's going to take a second. And that pushed. So now if I come back here, come this branch, you can see it's pending. Typically, this will take a second to run in the cloud. But if I come back to the pull request here, let's go pull request, add multiplication 2. It says the check started and the check just passed. So you can see unit tests are passing, and it'll now let me merge the pull request. So that's basically how to use continuous integration, or how to kind of navigate continuous integration when something goes wrong. This is a very useful thing to know at your internship, so that way if your build fails for any reason, you can at least try to troubleshoot on your own a bit before you go ask your senior for help. All right, another cool thing to know about are Slack bots. So I assume most of you guys have used Slack because we'll use it in some of our classes here, but Slack is basically corporate Discord. And just like you have Discord bots, you can have Slack bots that can post the CI or build status to a channel in your team's chat. Now, this is really cool because while the CI build we just did only took like 30 seconds, in a real code base where you might have hundreds of unit tests, integration tests, and a whole bunch of other things that need to run, it can typically take anywhere from 10 to 30 minutes to even an hour, depending on how big your code base is. So Slackbot can basically just give you a nice notification of when it's done running, which is useful. You can go do something else productive and just immediately find out your build, be notified of your build status whenever it's done. So once we see this glorious screen here, are we done? No, there's another step. But before there, I did want to sort of address a question that did get brought up by the audience in a live meeting. Someone asked, when is it worth implementing a continuous integration pipeline into your own project? And my answer to that is, first, you need to have some kind of tests, right? So obviously, if you're doing something like a small class project, this probably isn't the best use of your time. But if you have anything where you have test coverage, then you might as well add this, because, again, as we hope to demonstrate with a video we'll upload soon, setting up a basic CI pipeline like GitHub Actions is pretty easy. And it's another skill that you can add to your resume, something that you will use in real companies. And again, just really puts you ahead of everyone else, because like most college students don't know how to do this. And one other thing, I was right on the tip of my tongue here, is that if you don't have any unit tests, and really if you don't have any tests or any checks at all, then it's not worth setting up a continuous integration pipeline, because you can't, right? The whole idea is it's automated testing. So if you don't have tests, go write some tests first, and then once you've got some decent test coverage, go ahead and add some continuous integration and make yourself look like a pro 10x developer. So are we done? No. Next step, QA, or quality assurance. Now, QA testers, their job is to make sure that everything works, basically. Now, one thing to keep in mind is that not every team or every product has them. So this section might not even be applicable to you at all at your internship. But for those who do have them, they're typically the last check of your software's quality before it is released to the masses. And they will send your feature back if there is a bug. And this is something that you want to avoid. Reason why is because since they're the last step in the pipeline, you'll have to go through the whole pipeline again, which means you'll have to write new code, get it through the pull request process, go through the build pipeline, which again, especially with the pull request, because you got to go and get the other developers to review it. That can take a long time. So you really want to try to catch the bugs early, using the tools from earlier in this process. But if they find something, it's better than a bug going into production. So where does QA test their features from? I'll give you a hint. It's one of the big topics we talked about earlier, and it's the staging environment. Now, staging environments are useful for QA too, because they can go in and do all sorts of tests on the features, again, without having to affect real user data. This is useful for many reasons, but it allows them to test things that might not be released to the public yet. We talked about staging and the idea that you might have a staging backend or a staging database, but you can also have a staging version of your front end too, because typically it kind of depends. There are different titles such as QA or software test engineer, but a lot of them aren't going to be writing and running the code themselves. So they will have a link that they can go to and test everything out, not affect any customer data. And it's just another very important use of the staging environment. Now, we've got one step left in this process. Before we get there, there was another question that someone during a live meeting asked, which was, when you have this build pipeline and all these automated tests, are QA testers redundant? And my answer to that question is that I'm not qualified to answer that question, but there are, just as still being a college student, but people do have some different perspectives on this. Some things that might affect it would be, one, how many resources does your company have? Having manual QA testers does cost money. So if you're like a really small product or a really small team, you might not be able to afford it. Another factor is your software customer facing? If you're working on a tool that is only used internally within a company and isn't actually going to your end users, then you might not have a QA team. Is your software mission critical? There's a big difference between this bug here causes an image not to load versus this bug causes someone's heart monitor to stop working, right? So the severity of an error is another big factor there too. So there are a lot of things that go into it. A lot of developers have different opinions on it. I'm not going to say which one is right or wrong, but you should be aware of kind of the different factors that go into that. And also just in general, be aware of the different tools you can use for automated testing and implement it anyway, because typically if you can fix a problem before it gets to QA, it saves their time, it saves your time. They do other work too, such as often being the first ones to respond to bug tickets and support tickets from customers and kind of trying to reproduce those before it actually gets sent to the dev team. So now the last major step in this process, which is deployment, and hopefully continuous deployment. Now, continuous deployment is when you automatically deploy your code to production whenever you push new code to the main branch. Or, well, it doesn't have to be the main branch. It can be any branch of your choice. While a lot of people do set up their continuous deployment to run from their main branch, it's often common for people to have a branch called release. This is an example from the VS Code repository on GitHub. And it uses workflows just like continuous integration. So you can run just a deployment script instead of a test script in the workflow like we saw. And exactly what the script is going to look like is going to depend on the app type you have in a cloud provider. There's a lot of different factors, such as, are you running a VM? Are you deploying to a container, serverless? Which provider are you on? So we're not going to talk about the actual how the actual deployment process works, but just know that you can oftentimes you can put that into a script. And if we come back right here and just look at an example of our workflow. By the way, in any GitHub repo, if you click actions right here, you'll see a list of all the workflows you have. And the workflows are stored in something called a YAML file, which I'm going to go ahead and look at now. Or, okay, test.workflow.yaml. Click the wrong button. This is a quick example of what a workflow looks like. As you can see, this is literally just a list of steps here, and each step is basically a command to run. And as you can see, this is the unit test example earlier from our continuous integration, where we just go through and set up npm and then run our unit tests. If we wanted to make a continuous deployment script, we would just simply change this on push here to add it to specify so that it only deploys on a certain branch, so that this workflow only runs when you push to main, for example. And then you would change the script here from npm run test to some kind of deployment script that you have somewhere in your repository. So again, the exact deployment script will depend. And an important thing is that you have to provide a token often to your cloud service, which again is basically a password. Cannot stress this enough, do not put your API tokens directly in your deployment scripts, because if they go in your Git history, attackers can get them. I know I've said that like 3 times. I have to stress this enough because it is a massive security risk, especially with something like cloud tokens can cost you thousands of dollars if a bad actor gets a hold of it. So please, please, please do not put your cloud tokens or passwords or anything like that in the file. There's environment variables that you can configure, just like .env. You can configure it in GitHub itself. And once you've done that, you're done. You went through the staging environment, you got your pull requests approved, continuous integration passed, QA didn't find any bugs, and then you ran a continuous deployment script, you're running in the cloud, your project is out. Congratulations. Now, let's just wrap this up with a quick little recap here, and just briefly talk about how this fits into the larger DevOps picture. Now, DevOps is one of those new buzzwords that you've probably heard before. And first thing I can tell you is that it's not the newest Call of Duty. So you can go ahead and get all those MLG dreams out of your head. DevOps is a combination of the words development and operations. Now, development, those are things that we all know and have done before. So things like planning, software design, writing code, and then testing it. We know all about this. Operations, however, involves things like deploying your code, so the whole deployment pipeline that we just talked about, supporting it, so responding to bug tickets on call, and things like monitoring, so things like logging, observability. And with development operations, they often used to be done by very separate teams. And with DevOps, we're aiming to change that. So instead of having one side that is completely on their own, they work together, right? The development and operations peoples both work closely together and kind of break down those barriers between them. And there's typically 2 ways this happens. One, you could have separate development and operations teams, but they're in close communication with each other. Or 2, and this is from what I've seen more common nowadays, the developers are also responsible for operations. So you'll be writing code, but you'll also be responsible for understanding how deployment works, how monitoring and support works, that kind of thing. And there are a whole bunch of topics that kind of fall into the DevOps realms. We only touched upon a few today. So continuous integration and continuous deployment is one of them. Anything that involves managing like your cloud infrastructure, monitoring or observability, anything that involves containers and managing those, and really just anything that involves deploying or releasing your code. Now, if you're interested in this topic, we have a couple other workshops up on our YouTube here. You'll definitely want to check out Michael's Cloud Fundamentals workshop and Angel's workshop on logging and observability, which is really cool because he was actually intern at Grafana. Although unfortunately, the audio from that got cut out. If you've noticed, issues with Zoom audio tend to be a bit of a recurring theme here, unfortunately. But you can still learn a lot from just going through the slides. And we also have the link to the PowerPoint on our Discord channel as well. And the core idea that we want to walk away from here is the power of automation, right? A lot of the developer tools we use are command line tools. They use commands. And you know what the great thing about commands are? You can put them in the scripts. And when you can put things in the scripts, you can automate them and save yourself a whole bunch of time and just make what would otherwise be very time-consuming processes easy, and focus more on actually building your product and getting those features out. And that's the note that we're gonna leave off on for now. Thank you guys for checking in, and have a good one.